Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd have a look at this. A friend of mine asked me whether I would take a look at this for a friend of his. What we've got here, it's a early to mid 1970s Sony stereo amplifier. It's only a small one. It's only like a I won't say low end because it's Sony. I mean, this was really good quality kit, but it's probably on the lower end range of the Sony stuff. It's not a massively powerful amplifier or anything, but it is incredibly neat. It is a nice little amp actually, but apparently it's got an issue. From what the chap has said, what my friend has said, that the guy said, it makes a whumping noise when you're playing a signal through it. So I thought we'd have a quick look, see what we can do about it, see if we can diagnose the fault and hopefully repair it. So I thought the first thing we better do is we'll connect it up to some speakers and put a source into it and actually see what it's doing. We've got some test speakers here. They're actually old speakers off an old plasma TV, but they should be absolutely ideal for this, to be fair. They're only, I think they're 8 ohm and they're about 10 watts. Now this should be happy with an 8 ohm load as the speakers, and this amplifier is only 15 watts per channel, so them should do fine as test speakers. Let's hook this up. Only problem with some of this early 60s and early 70s stuff is the connections are a pain. They tend to use these screw terminals rather than binding posts or the little speaker clip terminals you get on more modern stuff, and they can be a bit of a pain to get your wires to connect to, but we'll get them in enough for us to test anyway. Put this one on. It's quite what you've got on this amp. You've got a phono input, both ceramic and magnetic. You've got a tuner input and an auxiliary input, and it's also got the input for a tape recorder, both in and out. So it was a reasonably decent little amp for its time. So I think these came out in around 73ish, and I think they were current to probably about 75, 76 from the little bit of research I've done on the thing. I have managed to get a copy of the it's not the full service manual, but at least it's got the circuit diagram, it's got some voltage test points and a couple little bits of information about the amplifier itself, just disassembly instructions, stuff like that. So like I say, it's not the complete service manual, but at least it's better than nothing. And although I do like a lot of this 70s hi-fi gear, I generally speaking have worked on a lot more British stuff than this Japanese stuff. You know, Leek, Rogers, Quad. Yeah, I've worked on quite a lot of their stuff. The Japanese stuff not so much, although I do actually have my main amplifier and my main hi-fi downstairs is a Sansui, a Japanese Sansui amplifier from I think 1972, and that is a fantastic piece of kit. That is a very, very nice amplifier. Right, I've got us plugged in there. Let's switch on. Make sure the volume's down. Everything else is set about right. We'll need a signal source, won't we? Well, I'll tell you what, first off, let's just switch it on and see. That's oh, there we go. And the volume's right down. So that's what it means about a whumping noise. And interestingly, that seems to be coming out of both speakers. So whatever the fault is, it's affecting both channels. Now I'd normally start to suspect something like that, possibly power supply related. But looking at the circuit diagram of this amp, the power supply is so ridiculously simple. It's unusually, actually, for a stereo amp, even a 15 watt one, well, it's 15 watts per channel, one like this. It only uses a single-ended power supply. It doesn't use a centre tapped power supply with a plus and minus rail. Like I say, it just uses a standard single rail power supply, which is quite odd, really. I think the best thing we're going to do, well, crack inside this thing and see what we can see. Unfortunately, I have read the disassembly instructions, and if you didn't have the disassembly instructions for this one, it'd I mean, you get it apart eventually, but it's not the easiest. You take all the controls off there and spin it over. And then we take, oops, we drop our screwdriver. In fact, I need a little pot or something I can put all, oh, that'll do. Yeah, that'll do. Little pot there that I can put all the bits we take off in. We have them knobs. We'll put the knobs in there so we don't lose them. Take that one out. Now, I don't think we need to take them front ones there out, because I think those are to take that front panel off, and to get the actual chassis out on this one, it actually has to be pushed out from the back. Or do you have to take them ones out? I'm sure it said you didn't on the let's try taking them out anyway. I'm sure reading through the manual before it said you didn't have to take them out. I could be wrong though. There we go. Let's see, try again. Oh yeah, so you did have to take them out. Okay, let's have a look. There we go. Oh wow. I did say Sony needed to be well built. But there we go. So essentially, as far as I'm aware, we've got our power supply section here. And we do have all the voltages marked on this circuit diagram, so I think one of the first things we're going to do is check some voltages. Actually make sure we've got the right voltages in the right places. Best we can anyway. Excuse me. And then, looking at the way that this has been, this is constructed. Well, there's our power supply with our output. Right, okay, hang on. So that, there. Right, what we've basically got, we've got a power supply section there, we've got the actual power amplifier section there, and then we've got the EQ, the bass treble control, and the pre-amplifier section along the front there. Looking at the way that this has been designed, I think it should, yeah. We've got that wire there that comes straight off the power supply that powers the power amplifier section. And then we've got this wire here, which comes off. It comes through a resistor, through some extra smoothing, and then goes off to power the preamplifier section. Well, that being so, right, what it should be possible to do is basically split this up. So if we disconnect what's powering the preamplifier section here and power the amplifier back up, if that whumping noise has gone, we know there's a very good chance it's actually it's the preamplifier section that's got the fault in it. If that noise stays when the preamplifier section's been powered down and we've still got that whump noise, then we're going to be looking, it's going to be something in the actual power amplifier section. Now the interesting thing is, there's very little in the power amplifier section that's really going to be shared between both sides, because essentially all this board is two mono amplifiers together on the same PCB, one for the left channel, one for the right channel. They're the output transistors of these. I don't know if you can make that out. So basically what we've got here, let me see if I can zoom you in a bit so I can point out to you. Right, there we go. You can see this a little bit better. Essentially what we've got here is we've got, if you split that down the middle, you've got two identical amplifier sections. So what we need to, like I said, the first thing we need to do is figure out, is the fault, I mean the fault could possibly be in the power supply section, but I don't think so. I doubt it, but there is a possibility if we've got one of the voltages has been pulled right down. I suppose that could technically be doing it. I mean, like if that I'm not sure. I think the fault's either going to be in the preamp stage or in the power amp stage. And I have a feeling it's possibly going to be in the preamp stage actually. I think there's more, looking at the circuit diagram, there's more things that are more commoned up on here. I suppose the first thing to do then, really, we'll disconnect the preamp stage, we'll fire it back up, and if the power amplifier keeps doing that whump 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 noise, then we know there's a good chance this is where the fault lies. Like I said, if it doesn't, then we're going to have to concentrate on that preamp section there, which will be a pain because it's a lot harder to get to than the power amplifier section here, but it's sod's law, and I'm pretty sure the fault's going to be in the hardest bit to get to. We are unplugged now, so I'm going to desolder this wire here, which is what actually powers up the preamp. Come on, melt. Let's just see if we can just slide that out of there. There we go. So let's disconnect that. Just stick that up out of harm's way. That's not going to touch on anything, is it? No. We'll plug back in. Now you don't have to be as careful as you are around, say, a piece of AC/DC valve equipment while powering it up like this, but you have to bear in mind that there is mains in here. There's mains that you can lick. This was made in the 70's. It's not modern safety standards. With the cover off like that, there's things you can touch in here and get access straight to live mains. Like here, that is a fuse there. And that's the mains input fuse. So like I said, across those two terminals there, you've got 240 volts straight for you to touch like that. The power switch around there, I noticed when I took it off, that's the same. So you have to be very, very careful when you're working on equipment like this with it open and you've got it powered up. It's only something to really do if you know, like I said, if you've worked on this stuff for a lot. Just remember which way's on. On's up, so switch it up. and we still have it. Right, so that pretty much, to me, makes me think that the fault is actually in this main power amp section here. Well, that's a relief. And what I can spot as well, there's a number of these capacitors down here. Yeah, let me just make sure that's off and unplugged. Right, you can make this out. There's one there, there's one on the same side there. That one not to as much an extent, but I think that these have been running hot. These are all, I think, the Nishikon. I think they're pretty, let me just double check. I can't quite, where are my glasses? Just grab my glasses. Ah, there they are. Well, they're not my best pair, but we'll do. Oh, the Nippon Kamicom. So like I said, they're not a cheap, nasty capacitor that's been used in this. But looking at them, it looks like these have been running hot, because if you look, let me see if I can. I'll zoom you back in so you can see. We'll look at these capacitors, and they're all the same brand. We notice how the plastic comes right over the top on these, and on that one there, and on them to a lesser extent. But look at that capacitor there, and that one, and that one. Can you see how it's basically the plastic shrunk back? Well, that happens when they get really hot. So I have a feeling that these capacitors here have been running really quite hot. I'm wondering whether also these, right, we maybe have a dry. I have a feeling that these electrolytics are possibly at their they may even be dry. That feels dry jointed. That one doesn't feel much better either. I have a feeling they've been running really hot. What I think I'm going to do is I'm going to pull these capacitors out, and we'll just test them. And we could be down to some just bad capacitors. It might be an easy fix, this. But that one down there, that one down there, that one. I said that one to a lesser extent. That one looks alright, but that one looks okay. But they definitely look like they've been running rather hot. I don't like the look of those. They've like got a black. Now I know they used to use like a glue to stick them down, but I also know that glue can go conductive over time. It's like that horrible black stuff. It's the really early stuff. I'm going to pull those out. I'll do one on camera, and then I'll probably just pause it and just do the other ones. Keep the length of the video sensible. But we'll pull one out now. Just make sure which way around it goes. I mean, you can test them in circuit, but to be fair, you don't. It's much better to pull them out of circuit and actually test them. I'll get you zoomed out so you're not getting quite a. There we go. You can see what I'm doing a bit now. You can test them in circuit, but to be fair, it is far better. Especially when it's easy enough to do like this, to whip them out of circuit and actually test them properly out of circuit. So that's what we're going to do. cap just doesn't feel right on the board. Let's get my other iron. I'll just try and draw them out. That's that one done. And that's that one done. Oh yeah. I'm not sure. It doesn't look healthy, that cap. Can't smell any. Ooh, can't smell any electrolyte, but that cap doesn't look too healthy to me. 35 volt 470 UF, so I've got plenty of them in stock. Let's just get it on the old ESR meter and see what that says. So we've got a 470, haven't we? 470 at just say 35 volts. Yes. So that should be nice and low. Hold on a minute, let's get the tester on. Right. Connect. Like that. Connect. Right, well that's coming up as 0.00 ohm. Let's just, we'll test that on a capacitance meter. That's either got excellent ESR or that cap's bad. That ESR tester is just that, it's just an ESR tester. It doesn't test the value of the capacitor. This does. It's coming out at about the right capacitance. It just feels, I just don't like the look of that cap. Being that they're 40 odd years old, I think I might change them anyway. Let's pull the other one out and have a look at the other one. Where's my thing gone now? There it is. Where are we? We're down there, aren't we? Unfortunately, when they built this as well, Sony are a bugger for it. They get a lot of manufacturers where they did have a tendency to get the assembly workers to bend the legs right over before they sold them. And it does make removing them a bit of a mare. I don't know whether it was where they got them to do it or whether that was just a standard practice. Oh, that one doesn't smell good. Oh, that smells nasty. It's not got that fishy smell, but it's definitely got an electrolyte smell about it. I don't know if you get that fishy smell so much with 70's stuff. It's more 80's, 90's, 2000's stuff. Right, let's have a look at this. It is coming up, the ESR is pretty decent. Test that other one again. But that cap just, it's got a smell to it. And it just smells like the old-fashioned electrolyte smell. Now that's the one that was coming up as 0.0 before, 0.06. Try it again. Yeah. Now, ASR wise, those are looking really good actually. 0.05 ohm. And well, yeah, same. But they smell horrible. They kind of smell like electrolyte and burnt rubber. I think just by the very fact that they're over 40 years old and I'm in here, I'm going to put some new ones in. I'm not saying that those are completely dead, but they've certainly, you know, they're on the end of their life. Just bear with me a sec, 'cause I'm just going to have to go and fish out some new caps for that. So back in a sec. Okay, I'm back, and I've got two nice RS replacements there. Now, I don't actually think these are the fault, but they are getting to the end of their life. We've pulled them out to test them anyway. Yeah, I could stick them back in and then be revisiting this amp in a couple of years' time, because they've gone. Like I said, they are, although they're showing okay, I mean, physically, if you just look at them, you know, they are getting to the end of their life, and one of them has got like an electrolyte aroma around it. I've got them in stock, so I might as well put new ones in instead of had to order them in or what have you. But like I said, I've got them here in stock, so just for peace of mind, we'll just clean these legs up a bit because they've been in storage for a while. There we go. Bent. Basically, I'm just giving the legs a quick scrape because they've been in a drawer in the attic for some time. Right, we'll stick these new ones in. In fact, what I'm going to do first is I'm just going to see if I can clean some of this gunk off the board. You can see, I'll just lift this up so you can see it. You can see where we've taken the two capacitors out from. There's like that horrible black gunge round them. I'm just going to do my best just to clean some of that away, because I don't think that's going to be helping matters. So I know that can go conductive over time. And that's a problem I found in old amplifiers in the past, where the like a glue they've used to secure some of the larger components down has actually gone conductive over time. Now, it does tend to be more in 80s stuff I've found that, but conceivably, and this stuff is horrible. It's almost like a liquid rubber or something they've used. Get it off the board. You do literally have to scrape it off the board. Yeah, I think we've definitely got some electrolyte leakage there, because it seems to have affected the board a bit in that one spot. We'll get the rest of that cleaned off a bit, and then we'll get some isoprop on that and just clean the board up. Yeah, it's horrible stuff. I think the idea was, you know, stop in transit, stop large components potentially becoming adrift, but after 40, you know, minimum 45 years, I've not found a date on any of the components on this yet, but I believe these were Well, the circuit diagram, the service date is dated 1972, and I think these were on the market till about either 75 or 76. So, you know, at its youngest, it's going to be 45 years old. Could be 48 years old. Dear me. Yeah. Try and get as much of this off as we can, I think. It does not come off easily though. We'll get a Q-tip. Ow! Let's try a little bit of, just a little bit of contact cleaner on the end of a cotton bud, and we'll go in with that. Well, that works quite well. Yeah, that's just helping just get the remainder of that off the board. Dear me. There we go, that's better. And what I should also do, just thinking about it, we could still have, say, like a short in there, which is shorting the outputs to the amplifier. So what I am going to also do is just lift the two inputs to the power amp before we try powering this thing back up again. Just to completely isolate, like I said, all this section from the power amp section, so we can be absolutely 100% sure that that's where the issue is. I'm pretty certain it is. It could possibly even be another one of these capacitors. But what we'll probably do, I've got all the, we might do some voltage checks actually after I put these in. There we go. Put them in. And solder them in place. It could conceivably be shorted output transistor or something like that, but I don't think it is. Generally speaking, that usually only affects one channel, and this is coming through in both channels. Go. There we are. And wires snipped off. Right, there we go. That's the two main capacitors there replaced. So that's just more a future-proofing thing than anything else, really. I'm going to lift the signal wires off the preamp on both the left and the right channels, So then, like I said, the preamp is then completely isolated. I mean, I could have done that before, actually, thinking about it. There we go. So that's the preamp completely 100% isolated from the rest of the amplifier. We'll power it back up and we'll see if there's any improvement at all. Switch on. And note there, we're still there. So we're now pretty certain that our fault is definitely on that power amplifier board. Those are our speaker outputs there. That's ground. And those are our speaker outputs. Just have a look at the circuit diagram, and let's next thing really is going to be checking voltages. We can basically ignore that whole side of the circuit because that's all the preamplifier section, and that is completely unhooked now. All we've got powered up is the actual power amplifier section, which is essentially the power supply there and this whole section here. That's what we need to concentrate on. And quite handily, this does have some voltages marked on here for us to check. So we've got Q702, which is the fortunately, this is quite a nice circuit diagram. Basically everything is marked on it. You know, even on the diagram here, you don't have to refer to another sheet. You can tell exactly what the components are. So we have a 2SC634A for the pre-driver. We've got a 25A678 as the driver, and then we have a there'll be two of them, and then we've got 25D291 as the power amplifier. Right. Which is though, yeah, which will be those two there. So basically what we've got, DC bias supply. What I'm basically looking for now is just to see where there's some some good test points. Unfortunately, one of the problems is that the resolution on this circuit diagram isn't exactly great. I might have to refer back to the computer and just see if I can enlarge this part of the circuit diagram, and then we can take it from there. Because like I say, I can see some of the voltages on here, but some of them I can't actually make them out, and I'm pretty sure you can do on the original PDF I printed this from. So what I might do is just go quickly nip back in there and just blow this entire section up, enlarge this section, and print that out. In fact, that's what I'm going to do, so I'll be back in a sec. Okay, I'm back. A few little issues, one being that my bloody printer's run out of toner, so I can't. So I was trying to print the circuit diagram. Basically, I was trying to print that part of the circuit diagram there a little bit bigger, so I could make it out easier. I have got my laptop behind me here, but I must admit I absolutely hate reading circuit diagrams off a laptop screen. So what I thought I'd do, I thought I'd carry on what I was doing before, and I thought I'm just going to check all the electrolytic capacitors in the actual power amp section. being, like I said, they are over 40 years old, and some of them do look like they might be running a little warm. I've checked a couple of them, and actually the ones that look the most distressed, they actually test for capacitance and ESR absolutely spot on. And I pulled this one. It's let me just get the circuit diagram here. It is C708, and it's 47 UF at 50 volts, and it's on part of the transistors, I think, that provide the DC bias for the output transistors. So I think if that was faulty, that would cause an issue. And the thing is, if I get my ESR meter in, oops, and we connect it up to the ESR meter. Oops, there we go. Probe open or ESR greater than 25 ohms. I don't think that's a happy capacitor. It's a strange one because that, like I said, some of these capacitors in here actually look like they've been running hot. They look like they've been, let me just get you up a little bit. I showed you before, didn't I? Oops. Let's get you in there. But some of those capacitors look like they've actually, if you look at the well, if you look at the top of that capacitor there, can you see how the plastic comes all the way over it? And they're all the same brand of capacitor. They're all the Nippon Kamicom capacitors. And if you look, like that one there, that one there, that one there, those two not to quite the same extent, but they've all, basically, the plastics shriveled back a bit on them. And you generally see that when they've been running very hot, or it's been hot round them. But, like I said, when I test those capacitors, they are coming spot on for both capacitance and ESR. Now I know I changed those two out, but the reason I changed those two out is because the old ones actually have a funny smell about them. It's not that fish smell you get with modern capacitors, but these older capacitors tended to use different electrolytes, and I think it is an electrolyte smell I can smell. So just for peace of mind, that's why I put two new ones in there. All the other capacitors, they've not got a nasty smell about them or anything, and like I said, they do all come up absolutely spot on when I test them, apart from that one. So I think what we'll do is we'll bob a new one in to replace that, and then we will give it a go. Now let me get my magic capacitor box out. I really need to order some more electrolytic capacitors because I'm actually getting incredibly low on quite a few values now. Let's see, that's no use. Like that. That is the correct value, but that's a 100 volt capacitor, where the old one's a 50 volt rated capacitor. That won't matter at all. There's no space constraint or anything, so it doesn't actually. You can't really go under on the voltage rating on the capacitor. So your value's more important. In fact, being that it's just really DC decoupler, it's just DC smoothing on the on a rail, it wouldn't matter too much if you went up a little bit on the value. You wouldn't want to go down on the value at all, but you'll see if you went from, say, a 47 to a 68 or something like that, it really wouldn't matter. Again, if you use a 100 volt rated cap to replace a 50 volt rated cap, providing it'll actually physically fit, you're not going to have a problem with that, but you couldn't do it the other way around. Right, let's just check the let's check that capacitor just to be on the safe side. This is a brand new capacitor, but switch the meter on. Let's short the probe to compensate. Right, there we go. Let's connect this capacitor up. There we go, that's got a really low SR, 0.22 ohm. So that's I'm sorry you can't see that, but if you look, that's a really good capacitor. As it should be, being it's a brand new one. We'll stick that in the board. Like that. And there's one other capacitor on the board that I haven't tested yet. After that, that is literally all the capacitors on the power amplifier, all the electrolytic capacitors on the power amplifier section, tested or replaced, so we know that they're all fit for service. If this doesn't cure it, then we're going to have to start. Oops, let me get you down a bit. I'll zoom you out a bit. You can see what I'm doing. If this doesn't sort it, although that capacitor is definitely bad, we'll have to start testing some voltages on this power amplifier section. Right, there we go. That's the new capacitor in place. Right, let's see if that's made a difference. The only one we haven't changed so far now, I'm not sure that's sitting okay. The only one we haven't changed so far is that one at the back there. What I want to say changed, so we've changed those two just purely because I didn't like the look of the old ones. The others I've taken out, I've tested them and they're absolutely fine. That was the only one that I'd found so far which was bad. And then so there's that one there which we haven't tested yet. But let's give that a quick try, like I say, because that capacitor was definitely not happy. Just make sure everything's off. Switch on. No, we're still there, still the same. What I will do is I will just take out and test that last capacitor there. I won't bother you filming me do that, because you've seen me do that many times. I will do that, and then we will have to go around. I'll have to get the laptop set up somehow so I can actually see the screen while I work on this, and we'll go and do some voltage measurements around the power amplifier section. It possibly could be like, you know, one of them transistors that's to do with the DC bias, something like that, that's at fault. But really, because the capacitors are the most likely thing to fail in something like this. I mean, as electronic components go, I think the electrolytic capacitor in general is the most unreliable electronic component out there. They seem to fail, with the possible exception of certain diodes. Certain diodes have a distinct failure rate, but the exception of them, I think certain ages of electrolytic capacitor, and after a capacitor has got past a certain age, they seem to be one of the most common faults. But that's not to say that you should just blanket change them when you find an old piece of kit. That's not always necessary. You have to take them on, take them on the merits. Anyway, actually, I'm going to just pause the video, get that last capacitor checked, and I'll fire back up if I find anything interesting out. If not, then we'll go straight into doing some voltage checks on the rest of that power amplifier board. So back in a sec. Well, that's just bloody typical, isn't it? Why when I stop the thing, the last capacitor, and yeah, that's gone. I've got another bad cap there. It's actually, one of the legs has actually rotted off the capacitor where it's been leaking. So yeah, we do definitely have a bad capacitor there. It's actually left one of the legs in the board, which I've just got to see if I can clear out now. So let's see if we can get the rest of that capacitor leg out of there, and we'll look to put a new cap in. Get you out of there. Come on, out you come. There we are. Yeah, so we definitely had a bad capacitor there. Just see if I can clean some of that muck off the board where that cap's actually spewed its guts a little bit. And get a little bit of contact cleaner on a Q-tip. Give the board a clean around, get rid of as much of that muck from the capacitor as we can. And see it's, yeah. And then I need, because I can't even test that one being the one of the legs has dropped off it, but yeah, so we need a 47 UF capacitor at 25 volts. Let's see what we've got. Got up there. What are these? Well, those are 100s. Those are no use. Right, you're just going to have to bear with me, chaps, because I'm just going to have to see if I can find a 47 UF at 50 volts I can stick in there. So, again, back in a sec. A bit of a faff, but I managed to find a couple of my parts bins, so we'll stick one of these in. I've definitely got to order some more electrolytic capacitors, because I'm definitely getting low on my stocks. I'll just bend them over slightly to hold them in place while we solder them. There we go. That'll just secure it in place while I solder that up. And I can't solder with a Q-tip. I need solder for that. There we go. Right, let's give this a try. This new capacitor in place. There we go. Right. So there's the new cap in position there. That's, all the other electrolytics have been tested. Any that were slightly looking iffy or out of spec have been swapped out. So we'll give the power amp section another try now. If that works, we can connect it back up to the preamp section, and we can actually see if the amp's going to function now. So that's off. This is the moment of truth. It's going to start wumping again. We have no wump. We are wump free. Yep, we appear to be wump free. Right, so the next thing I suppose we better do is we'll connect the preamp section back up. We will connect the preamp section to the power amp section, and we'll see if it works then, and then we'll feed a signal into it and see if we actually get a decent signal out of it. So we might as well do that on camera. It's not going to make it too much longer, is it? So let's we'll resolder. In fact, we better just switch off and unplug. Be safe. We need to reconnect that wire in there. In you go. There we go. We'll solder that back into place. There we go. And we'll solder the signal wires back from the preamp onto the power amp. And one of the best ways when you are working on something like this is to isolate if you can. That's why one of the reasons I like this 70s stuff and earlier. It's easy to work on, really. You know, whether it's just a record player or it's an amplifier like that, they're all really quite basic. This even more so than a lot, because we've just got a single rail supply. You've got no ICs, it's all just done with transistors. There we go, so that's the two signal wires reconnected. We've got power back to the actual preamp section, so we'll give it another quick test. Make sure there's no other faults. I mean, we could have two faults. We could have a fault in the preamp section as well, but we certainly seem to have got rid of the whump noise from the power. From the sorry, just bear with me a second, folks. It's nothing that I can't sort out later. Right. Again, we'll just plug back in. Switch on. Let's power back up and we'll see whether, again with no nasty noises. Just check on the front, just so we can select one of the, let's select AUX. That's auxiliary there. AUX in. The volume's a tiny little bit crackly, but it's not terrible. Actually, it's pretty good. So let's find, let's put a signal source up it and let's see what we can get out of it. Now, somewhere around here, I've got a. There's my old phone. That's got music on it we can use. And somewhere I should have a phono to 3.5 jack cable. We can actually connect it up with. Well, where's that gone? Sorry, just a sec, folks. I'll be right back as soon as I find what I've done with that cable. You know, I don't know where cables go sometimes, but anyway, there's more than one way to skin a cat. I've got one of these 3.5 to phone jack adapters here, and then I've just got a standard audio phono to phono. So if we connect that up like that on that end, that can go into my phone. Pull that off there, and then we've got standard phono jacks to go into the back of the thing. So we'll go in, we'll try the AUX input. We'll go into the AUX input there. Just turn the volume down so we don't want to deafen anything. Switch on. Yeah, we've got something there. Right, where's my old phone? There it is. And I think I can play. So I think I've got something on here that I can play that's royalty free. So hopefully we'll get hit with a copyright strike. Let's try. There we go. That doesn't sound bad, does it? Actually, that sounds very good for a little amp. I understand why he was keen to get this repaired. About halfway. Left and right. Yes. Some bass. Full treble. Delete. The bass and treble controls are very nice on it. I believe we have a loudness control as well. Yes, we do. That's with the loudness in. Got a filter. That's a high cut filter. That's stereo mono switch. That's your monitor for if you're using it to record with a tape recorder. Then we've just got phono, tuner and our aux control. Turn that down again. That does sound very, very nice. Well, what I'll do is I'll just switch that. Oh, hang on. Stop that. Shut that off there. What I'll do is I'll just pause the video. I'll get this thing put back together, and we can have a final quick look at it and a quick final play. So back in a sec. Okay, we're back, and as you can see, I've put it all back together. There's one little place on the case at the back. Oh, sorry, I think it's on that side there where the plastic wood effect is actually coming away from the surround, so I will just get a little bit of glue and just stick that back before it goes back. And at the back there also, you can see it's just lifting ever so slightly there. I'll just use a little bit of glue or some double-sided or something and just stick those things back before it goes back, because I hate for it to get caught and torn. Because actually it's in a really, really nice condition, this amplifier. It's not all scratched and bashed about like a lot of these that we find nowadays. It's obviously been really well cared for, and hopefully now it should give quite a few more years good service. We'll switch it back on and I'll let you have one final listen to it. Again, I've just got some royalty free. Hopefully I can get this to play on my phone. There we go. Treble on the bass in. I'm going to reduce that a little bit. Take the loudness off. Filter. Put the high filter back in. That's obviously running in stereo mode at the moment. Press that in and now it's in a bridge mode, so it's in a mono mode. A little bit of extra kick with the loudness. But yeah, that's a really nice little amplifier. You know, all you want is an amp just to fill a reasonable sized room. You don't want to fill a big room. It's great. Nice pair of little bookshelf speakers with that, and it'd be a really, really nice amp to use. especially with it's got the advantage that you've got both a ceramic and a magnetic phono pickup on it, so you can run most turntables with it. You're not limited. Hopefully, like I said, the chap's going to be quite pleased to get that back. It is just a really nice little amplifier. It's no frills, it's nothing special, it's not mega powerful or anything like that. Only 15 watts per channel. But for, you know, a listening room or something like that, that's perfectly adequate. Yeah, it's great, that. Anyway, I'm going to leave it there for now. Like I said, I hope you enjoyed this little repair of this 1970s hi-fi amplifier. So, thanks for watching and goodbye.